Hi folks, and welcome back to Physics with Captain Rod here. What I'm going to do here is walk through an example of relativistic time dilation here. So we're going to imagine a pair of twins here. Bob and Tim here. We'll call this guy Bob, this guy Tim. And imagine that these are identical twins. And Bob, we're going to imagine, gets on a rocket ship that can travel at 0.95 the speed of light. So the velocity of that ship, 0.95 c. And Bob is going to go here to the planet Vulcan, 10 light years away. And then he's going to return to the Earth. And what we're going to do then is take a look at the time difference, or the times as recorded by both Bob and Tim. We'll start with Bob. So for Bob, it's just a really simple speed distance type of problem. We've got his speed is equal to distance over time. Now the distance would be 20 light years if he travels there and back again over some sort of time here. And the speed, now we can write it different ways. A convenient way to write the speed in terms of in problems like this would be, instead of saying 0.95 c, let's call that 0.95 light years per year. And what we can do now is just solve this for t. So the time as recorded by Bob is going to be equal to, let's see, 20 over 0.95. I'm going to go ahead and calculate a value, which is 21 years. So imagine that these two twins were, say, 10 years old. When Bob returns, he's now 31. Now we're going to take a look at what happens as far as Tim is concerned. Now Tim is observing Bob traveling at 0.95 c for a total distance of 20 light years. The relationship between the two observed times looks like this. I'll put t prime here, which is going to be for Bob's time, times the square root of 1 minus v squared over c squared, some people call this the relativistic fudge factor, is equal to t, the time observed by Bob. Putting in values here, we're going to have that t prime times the square root of 1 minus, v is 95% the speed of light, so let's just call that 0.95 c, and then squared. Now by the time you put 0.95 c here, the c's are going to cancel. We're just going to end up with 0.95 squared on this right hand side, is equal to t, the time observed by Bob, which remember was 21 years. So when we solve this for t prime, let's see, we get 21 divided by 1 minus 0.95 squared, and then square rooted 67 years is what I got out of that. Hopefully I did that right. I'm going to double check that one more time. 21 divided by 1 minus 0.95 squared, square rooted 67 years. Okay, so ages now, he's starting at 10 years old. Tim here is now 77 years old. Bob is coming back at 31 years, and they now look drastically different. So this is an example, again, of relativistic time dilation. I know it seems like it's almost magic and can't be possible, but I assure anybody watching this video, this effect has been verified by experiment time and time again. And it's a real fact. This is how the universe works. So I hope that this example helps demonstrate how to apply special theory of relativity, at least as it pertains to time dilation and what I call the relativistic fudge factor. Have a great day.